Hi friends, I hope you could have listened the previous video, that is construction and working of p-n junction diode. In this video, we will study about VI characteristics of a p-n junction diode. However, I quickly review the forward bias and reverse biasing of p-n junction diode. Then only we can study the VI characteristics of p-n junction diode clearly. So let us start with the forward biasing and reverse biasing. P-n junction diode in forward bias. Forward bias means positive terminal of the battery is connected to P type and negative terminal of the battery is connected to N type. Let us study the p-n junction diode in forward bias. Before we switch on, the potential barrier is already developed and corresponding depletion region also created in the junction. Now this circuit is switch on by inserting a key. The holes from positive terminal of the battery reach anode in P type. The electrons from negative terminal of the battery and reach cathode, that is N type. The electrons in the N type are pushed towards the depletion region by electron in that, so that the depletion region is disappeared when the electrons are diffusing and they combine with the holes in the P type. Now the electron in the P type are attracted by holes in the anode. In this way, the current flows in the p-n junction diode. The electron flow moves from N type to P type. So remember, diode conducts the current in forward bias only. P-n junction diode in reverse bias. Reverse bias means positive terminal of the battery is connected to N type, negative terminal of the battery is connected to P type. Let us see what happened to p-n junction diode in reverse bias. Before we switch on, the potential barrier is already developed and corresponding depletion region also created in the junction. Now the circuit is switch on by inserting a key. The electrons from negative terminal of the battery reach anode in P type. The holes from positive terminal of the battery reach cathode in N type. The holes in the cathode attract the electrons in the N type. The electrons in the anode attract the holes in the P type. Now due to lagging of charge carriers nearby the junction, the depletion region is increased. If depletion region is proportional to resistance, and hence the electrons cannot move further. So remember, diode does not conduct the current in reverse bias. Practically, at low voltage, there is a small amount of current passes through p-n junction diode. This is because of minority carriers in both regions. See, in P type, minority charge carriers electrons are present. In N type, minority charge carriers holes are present. If we apply some voltage across the p-n junction, the electrons from anode just pushes the electrons in the P type. The holes in the cathode just attracts the electrons. In this way the current flows. But there is only very small amount of current is passed. So remember, at low voltage it conducts minimum current. Further, if we apply more voltage across the depletion region, whose thickness is noted as small d. Here thickness of depletion region d is constant, where the voltage is increased. So the electric field is getting depletion region. In the depletion region, large number of atoms are there. The strong electric field easily get ionized all the atoms. That means break the atoms and hence separate the electrons from it. Now there are plenty of charge carriers are formed. These separated electrons push the electron in the N type to cathode, and these electrons occupy that holes, and the anodes nearby the P type are just cross to the holes in the P type. In this way, the current flows in a certain direction from P type to N type. So remember, at high voltage, it conducts the maximum current. Now let us study about what is VI characteristics. The character of PN junction diode under voltage is nothing but VI characteristics. Here we are going to study the variation of current with respect to applied voltage. Two methods to apply the voltage across PN junction, that is forward characteristics, that means the PN junction diode in forward bias. Then reverse characteristics, that means the PN junction diode in reverse bias. VI characteristics of PN junction diode in forward bias, which is called forward characteristics. This circuit refers PN junction is connected in forward bias, that is positive terminal of the battery is connected with P type and negative terminal of the battery is connected with N type. Here battery with crossed arrow refers voltage variator, so we can vary the voltage. Voltmeter is connected across PN junction diode. A milliammeter is connected in series to PN junction diode. If we vary the voltage, we can take ammeter and voltmeter reading. To draw VI characteristics, we have to consider x-axis and y-axis, taking Vf, that is forward voltage, along x-axis, If, that is forward current, along y-axis. Every diode has a potential barrier. For example, the silicon PN junction diode has the potential barrier is 0.7 voltage. We increase the voltage from 0, no current is passing through the PN junction until it reaches the barrier voltage. So up to 0.6 volt, no current passes by PN junction diode. At 0.7 volt, the current starts to increase. Now the depletion region is shrinking. After increasing to a certain voltage, there is suddenly increasing the magnitude of the current, but in terms of milliampere. The current is directly proportional to applied voltage. Now the depletion region is totally abolished. All the values are plotted and connect with line. The slope line is extrapolated to x-axis, which meet at x-axis, that is called knee voltage. The portion looks like a human knee, that's why it is called as knee voltage. One thing, when there is a current, there will be a certain resistance. Then to get forward resistance RF, you have to draw a right angle triangle as shown in the figure and find out del V and del I by taking the horizontal lines and vertical lines and measure the values. From Ohm's law, V is equal to IR, R is equal to V by I. Here RF is equal to del VF by del IF. RF is forward resistance, VF is forward voltage, IF is forward current. Here RF value may be from 270 ohm to 1000 ohm. Let us study VA characteristics in reverse bias. VA characteristics of PN junction diode in reverse bias called reverse characteristics. This circuit refers PN junction is connected in reverse bias. That is, positive terminal of the battery is connected to N region, negative terminal of the battery is connected to P region. Here, a battery with crossed arrow refers voltage variator. Using this, we can vary the voltage. A voltmeter is connected across the PN junction diode. A microammeter is connected in series to PN junction diode. If we vary the voltage, we can take ammeter and voltmeter reading. To draw VI characteristics of PN junction diode in reverse bias, we have to choose minus X and minus Y axis. Here VR refers reverse voltage, IR refers reverse current. Here the characteristics is different. When it is switched on at low voltage, from that moment minority charge carriers are start to move. That current is very small, which in terms of microampere. So when the voltage increases, the current increases abruptly. This is because of atoms in the depletion region are broken by the electric field, and hence electrons are separated from the atom. It is called ionization. So large number of charge carriers are formed. Due to this breakdown, current value is increased. Connect the dot lines, and this slope line is extrapolated to x-axis. That point is called VB. Here VB refers breakdown voltage. Breakdown voltage is nothing but is the voltage. There is a sudden increasing in the current value is called the breakdown voltage. Here also we can calculate the reverse resistance using the same procedure followed in forward characteristics. The reverse resistance is equal to del VR by del IR. Here RR means reverse resistance, VR refers reverse voltage, IR refers reverse current. This figure refers VI characteristics for PN junction diode, that is the combination of forward and reverse characteristics of PN junction diode is as shown in the figure. Here remember, in forward bias knee voltage presents, in reverse bias breakdown voltage presents. Thank you.